Okay, this whole chapter so far has been about parallel lines. We're also going to talk about perpendicular lines here because we're talking about slopes. And what's interesting is they have some nice relationships. Let me actually color code this here. We'll do perpendicular in red. So for parallel lines, they have the same slope. So if I say line parallel to y equals 3x plus 1, well, all I have to do is look at the slope and know that the new slope is also 3. So the slopes have to match for parallel lines. For perpendicular lines, it's a little bit different. What we're going to do is we want slopes whose product is -1. Now, let's do a little side thing here. Perpendicular to y equals 3x plus 1. Again, I'm going to identify the slope and think, what do I need to multiply by 3 to get -1? Now, what's nice is there's a pattern. You take the reciprocal of the slope that you know, and you flip it over, so I'd get 1/3. But a positive times a positive is always going to give me a positive, so all I have to do is make it negative. And there I go, 3 times -1/3 equals -1. That's my slope of my perpendicular line is -1/3. So if you're given the two slopes, you can just multiply them, see if they're -1, and then you know that two lines are perpendicular. If you are going to be using it, you find what's called the opposite reciprocal. My pad keeps on sliding. Reciprocal. Opposite just means minus. Reciprocal just means flip the fraction bar. Flip it over on the fraction. A very important thing here, if you remember way back in the beginning, we had a horizontal line was always 0/5, and for the vertical, we always had some number over 0. So horizontal and vertical lines are always perpendicular. I mean, you know that from every coordinate plane you've ever looked at. The horizontal and vertical lines are always perpendicular. But the way we do that is 0 and undefined are the two relationships there. Now, how are we going to use this? We're going to take a look at some lines and try to determine if they're parallel, perpendicular, or neither. And the way we're going to do that is we're going to find the slopes. So really what the first thing we need to do is what 2 points are paired up together. A and B are paired up, so A and B, we'll find the slope of that line. And CD are paired up, so we'll find the slope of that line. And then we'll kind of compare them. If they match, the lines are parallel. If their products are -1, then it's perpendicular. And anything else, we just say it's neither. So, slope of AB. So, 1 minus -1. Oh, sorry. About -5. Almost mixed up my x and y coordinates there. And 1 minus -1. So we get 6/2 or 3. And we have slope of CD. Now, at this point, we still can't determine anything because we only know one of the slopes. We need to know the second slope to be able to figure anything out. 1 minus 2 over 6 minus 3, and we get -1 over +3. And you can see there those slopes, we already kind of did an example, 3 times -1/3. Their product is -1, so I would say AB is perpendicular. Remember, use the upside down T for perpendicular to CD. Now let's plot the points to figure this out here. +1, +1, +1. -1, -5. 1, 2, 3, 4, 5. And let me draw a straight line between those two. So that is point B, and this is point A. And we'll draw a straight line there. Ooh, my straight edge was a little bit off. I need to actually get a ruler for my straight edge instead of using, I'm using the side of a map right now. Now let's find CD. We'll do that in blue. That's 3, 2, 1, 2, 3, 1, 2, and 6, 1, 1, 2, 3, like that. And so that is C and D. And we'll draw a line through there. And if everything is done correctly, I should have perpendicular lines. And if you take a look at it, yes, that looks like they're perpendicular there. So we have verified our answer.